Sometimes the best way to really get a handle on our world is to try and see it again for the very first time. And that's exactly what we're going to do. We're taking a tour of our planet, all through the wonderfully simple lens of a children's book, my Encyclopedia of Very Important Things. So let's dive right in. And this quote right here, this is our jumping off point. It really gets to the heart of it all, doesn't it? Our planet isn't just some random rock floating out there in space. It's our home, and it is a very, very special place. We're going to explore exactly why it's so special, from the biggest cosmic scales all the way down to the bottom of the ocean. All right, so to really appreciate our home, first we've got to zoom out. I mean, way, way out. So our first stop is a trip into space to get a bit of cosmic perspective on this planet of ours. And what's amazing here is you immediately get this incredible sense of scale. Earth isn't just hanging out there by itself, it's part of this huge cosmic family called the solar system. We're just one of 8 planets, all making this constant journey around that massive, life-giving star we call the sun. So what even is a planet? Well, the book breaks it down really simply. It's a big, round object out there in space, and they basically come in 2 main flavors. You've got the rocky ones, like Earth, and then you have these enormous balls of gas, like Jupiter. Each one is its own unique world. But here's the kicker. Out of all the planets we've found, not just in our solar system, but everywhere we've looked, this is the most important part. As far as we know, Earth is the only one where anything can actually live. That fact alone makes this little blue marble of ours pretty much priceless. Okay, so we've seen where we fit in the grand scheme of things. Now let's zoom back in and focus on the constant motion, this kind of dance our planet is always doing in space. I mean, it's the classic kid question, right? We've all wondered it at some point. The sun is there all day, and then poof, it's gone. But does the sun actually go anywhere? Well, the answer really is all about your point of view. Turns out, the sun doesn't move at all. We do. See, the Earth is constantly spinning on its axis, kind of like a top. When the part of the world you're on is facing the sun, hey, it's daytime. And as the planet keeps turning, your side eventually faces away from the sun, and that's nighttime. It's just a beautiful, non-stop cycle. And this is where the 2 biggest rhythms of our lives come from. That daily spin, it takes about 24 hours, and that gives us 1 day and 1 night. But at the exact same time, the Earth is on a much, much longer trip, a 365-day journey all the way around the sun. And that, of course, gives us our year. We've seen our planet from the outside, we've watched it spin and orbit, so now let's do something really cool. Let's peel back the layers and take a little trip deep, deep inside the Earth. I absolutely love this analogy from the book. It's so clever. If you imagine the Earth as an apple, the crust, that's everything we stand on, all the land, all the oceans, it would only be as thick as the apple's skin. Just think about that. Everything we've ever known exists on this incredibly thin, fragile layer. So what's underneath that apple skin? Well, there are 3 more layers. Right below the crust is the mantle, which is mostly solid rock. Go deeper and you hit the outer core, which is this churning sea of liquid hot metal. And then, right in the very center, you've got the inner core, a super hot but solid ball of metal. So you've got this layered planet with this incredibly hot engine at its center. All that heat creates these unbelievable forces that are constantly at work, always changing and reshaping that thin crust that we live on. And that crust we were just talking about, it isn't one solid shell. It's actually cracked into these massive pieces we call tectonic plates. They fit together like a giant jigsaw puzzle. And here's the thing, they are not sitting still. They're slowly floating and grinding against each other all the time. So what happens when these colossal puzzle pieces smash into each other? Well, this isn't a quick process. We're talking over millions and millions of years. The pressure just builds and builds, and it starts to buckle and fold the Earth's crust, pushing it up higher and higher, until eventually you get a whole mountain range. But sometimes, instead of a slow, steady push, those plates get stuck, and the pressure builds, and then they suddenly slip. That violent jolt releases a tremendous amount of energy, and that's what we feel as an earthquake. But how do you even begin to measure that kind of power? Well, we do it with something called the Richter scale. Now, tiny little quakes, like a 1 or a 2 on the scale, are happening constantly, and we don't feel a thing. But when you get to a high number, like a 9, you're talking about a massive, massive release of energy that can be incredibly destructive. All right, for the last part of our tour, we're going to explore the two big fluid envelopes of our planet. We're talking about the huge oceans that cover it and the layered atmosphere that protects it. Let's start from the ground and look up. That first layer of air, the stuff we're breathing right now, that's where basically everything happens. All our clouds, the wind, the rain, every bit of weather you can think of, it's all happening right there.
But if you go higher up, things get a little different. This is why jet planes fly way up there, to get above all that bumpy weather. And this is also where you'll find something you can't see but is absolutely crucial for life: the ozone layer. It's like an invisible sunscreen for the entire planet, protecting us from the sun's most harmful rays. And if you go all the way to the very top, the atmosphere just gets thinner and thinner until it fades away into the blackness of space. It's up here, in orbit, where we've put our technology to work, all our communication satellites, and of course, the amazing International Space Station. Okay, so from the top of the sky, let's take a dive into that other great envelope, the ocean. Near the surface, in what's called the sunlit zone, it's just an explosion of life, right? It's warm, it's bright, and you get everything from vibrant coral reefs to massive schools of fish. But the deeper you go, everything changes. The light disappears, it gets freezing cold, the pressure is absolutely crushing. And yet, life finds a way. This is where you find these incredible creatures like the anglerfish that literally create their own light to survive. It's like visiting an alien world that's right here on our own planet. So, from the edge of space to the bottom of the sea, you start to see our planet as this amazing interconnected system of wonders. And looking at it through this simple, clear lens, well, it's just a powerful reminder of how much there is to appreciate and, frankly, how much there is to protect. Our little tour ends here, but that curiosity shouldn't. It just leaves you with one question. What's the next very important thing you want to understand?